All right, so progress check review. All right, the very beginning of your progress check, you'll be getting a formula sheet. I've crossed out everything that's not going to help you. Right here, these are the only things that are going to help you. The definition of logarithms, maybe the average rate of change. Definitely the quadratic formula. You also need to know the factor theorem and remainder theorem. There are questions based on that. And then down here is marking period 3. So starting from the first question, asks, given a function defined by g of x, what is the degree of g of x? Remember, degree is the highest exponent after you multiply everything. Well, that has just an x. That would be an x squared. If I have an x times an x squared, I'd be getting, since it's a negative, you get negative x cubed and then some other stuff. Highest exponent would be 3. It's also asking for the zeros. When does this cross the x-axis, or what is the solutions here? Well, you got one thing there. Oops. You have just an x, so just an x means I have a 0 of 0. I look at the other part of the factor. I've got x plus 3. That means my 0 is minus 3. Your zeros are always opposites of whatever occurs in the factor. All right, now it's time for end behavior. As x goes to infinity, remember infinity is the right side. Negative infinity is the left side. You could put this in a calculator and look at the graph. Or if you look at the degree, it lets you know what the graph already looks like. Well, the degree is 3, which means the left and right sides are not doing the same thing. It's also negative, and that negative means that the end behavior, at the very end, it goes down. So it should look like this. Well, the graph doesn't look like this, but the ends should look like this. So if I go to the right side goes down. Down is negative infinity. Left side goes up, positive infinity. So you could graph it, but if you know the degree, and if it's positive or negative, you still should be able to figure out the general shape of the graph. All right, number 2, the polynomial function is defined by h of x. First, finding the degree, well, I got 1x, 3 x's, 2 x's, which means at the end I've got 1, 2, 3, 4, 5. You're going to get x to the 5th and a bunch of other stuff. I don't care about the other stuff. I only care about this. My degree is going to be 5. To get the zeros, you look at each of the factors. My first factor is x. That means I have a 0 of 0. Second factor is x minus 2, which means I have a 0 of 2. Plus 1, which means I got a minus 1. Right. I have an odd degree. Actually, no, it looks like I made a mistake. 1, 2, 3, 4, 5, 6. That should be x to the 6. My bad. So that should be a 6. So 6 means it's an even degree. Should have looked at my paper. Which means it's even and positive, which means the left and the right sides are going to be doing the same thing. The inside could, I don't know, look something like this maybe. So if I go to the right and if I go to the left, both ends of the graph are going up, up. If I'm going up, that's infinity. Yep. And then for the third one here, degree again. So that's a 3. The 3 doesn't really do anything. So I got 1x, 2x, 3x. That means the beginning of your equation is going to be negative 3x cubed and a bunch of other stuff. The degree is 3. My zeros are, the 3 doesn't do anything to the zeros. Negative 2, positive 3, negative 6. Negative 2, positive 3, negative 6. These are my 3 zeros. Now, it's negative, and it's an odd degree, meaning the left and right sides are not doing the same thing. Your graph will end up doing something like this. The left side is going up, the right side is going down. The right side, infinity, is going down, negative infinity. The left side, negative infinity, is going up, positive infinity. Right, next one. Here they're asking us to graph the function, identify the number, and type, real or non-real, of zeros. Well, if you look here, there's a square, there's two x's. That means there are two zeros. So the degree always tells you the number of zeros. In fact, everything on this page is 2. See, squared, 2. Even if you go to problem C, guess what? 1, 2, there are 2 zeros. It's almost like asking the degree. It wants the type of zeros, however. Well, what is one of my zeros? One of my zeros is 4. Well, if I have one zero that exists on like the real axis, then the other one has to exist. So it's actually 4 repeated twice. So these are real zeros. If I actually look at the graph, you can get this either through a calculator or just memorize the shape of the graph. This is what your graph should look like. So the zeros are real because it does cross the x-axis at some point. Looking at this next one here, x squared plus 1, the graph here would look like this. And then 5 here. So this graph does not cross the x-axis. It still has 2 zeros, but they are non-real zeros. So they have something with I in it. So whenever it crosses the graph, it lets you know if it's real or non-real. So this has 2 non-real answers. Last one here, x minus 2 and x plus 3. So it would cross at minus 3, and it would cross at 2. So you actually know the zeros are already real. And the graph would look like this. 3, 6, 4, 6. And then 2 down here. So how did I obtain this graph? I got lazy. I did second table in the calculator. So yeah, there's nothing wrong with using that. So 2 real zeros because it crosses the x-axis. Next one here. So these are now solving quadratic equations. So for here, we definitely would be using the quadratic formula. You don't want to use it too much because you may not simplify it correctly. For this first, before you even start, you want to look and see if it's factorable, because that's an easier method than quadratic formula, or if you could just use square roots. So I can't use square roots. Is it factorable? Does anything multiply to 25 and add to 8? There is nothing, so this must be a quadratic formula problem. So there's my A, which is 1, because I don't, that's a 1 there. B is 8. C is 25. So let's just jam this in the quadratic formula. You do not need to memorize it. It's in your front page. Negative b plus or minus square root of b squared, 8 squared, minus 4 times a, which is 1. You don't even have to write the 1, times c, 25. Divide everything by 2a, 2 times 1. I can simplify this further, certainly. Negative 8 plus or minus square root of 8 squared is 64. 4 times 1 times 25, that's negative 100. All divided by 2 times 1, which is just 2. There we go. 64 minus 100, that's negative 36. Remember, you can't leave a negative in a square root. It's technically correct, but it's not written in the correct way, so it's bad math grammar. So remember that negative, you've got to represent that by putting an I outside the square root. However, the square root of 36 can be reduced to just 6. So you can actually just combine the 2 steps together and do plus or minus 6i divided by 2. You could leave your answer like this. This is totally acceptable. However, if you want to divide it out, you can. 8 divided by 2 is 4. 6 divided by 2 is 3. 3i. So this is the most proper way to write your answer. You don't have to do this, but it's the prettiest way. There you go. So negative 4 plus or minus 3i. All right, next one. You could use the quadratic formula, but that is a waste of time in my opinion. Look at what you have. You have x squared and a number. If you have x squared and a number, this is the easiest type of solving that you could get. So I subtract 9 to both sides. So now that I have this x squared equaling a sole number, I can now use square roots. So I'm going to take the square root of both sides. Square roots and squares cancel. Remember, when you do use square roots, there's always two answers. You can't just leave it as square root of -9. Plus or minus square root of -9. Again, square root of -9, I mean, it's technically correct, but it's not written correctly. So we got to change this up. Meaning I need an I somewhere. Also, the square root of 9 is 3. So this becomes plus or minus 3i. So again, this is because for two reasons. That negative means there's an I. The 9, the square root of 9 is a 3, so you combine two steps to get 3i. Okay, moving on to the next one. I've got three things. I can't use square roots here. Let's subtract this 24, set it equal to 0. That means nothing, so I got x squared minus 5x minus 24 equals 0. Now we want to think, is this factorable? What numbers multiply to 24 but add to 5? Well, I got 1 times 24. That's the easiest. 2 times 12. 3 times 8. 4 times 6. Anything else? I don't think so. Which one of these make 5? It's got to be 3 and 8. I could do 3 minus 8 to get 5, negative 5. So I would factor this. This would become x plus 3, x minus 8. And you want to double check. 3 minus 8 is negative 5. 3 times negative 8 is negative 24. So this has now been properly factored. And remember, the zeros are always the opposites of what goes in the factors. So x plus 3, well, the answer is negative 3. X minus 8, the answer is x positive 8. So there I have my two answers. You should always have two answers with quadratics. All right, next one here. I got x squared and a number. X squared and a number means I can use square roots. So move the 7 to the other side by adding it to both. X squared equals 7. Well, this one's nice and pretty. There's no weird negatives in the way. Take the square roots of both sides. These cancel. X equals, and remember, after square roots, you always must account for two answers. X equals plus or minus the square root of 7. You could put this in the calculator and get a hideous decimal, but I would prefer you leave it in this form. Leave it as a radical. And then last one here, this one is also a factoring problem. What multiplies to 12? We got 1 and 12, 2 and 6, 3 and 4. The only things that make 4, 2 and 6. So let's factor this out. You've got x plus 2 and x minus 6 equals 0. Well, great. These are factors. Just double checking. 2 minus 6 is negative 4. Correct. 2 times negative 6 is negative 12. That's also correct. Now I can just find the zeros. The zeros are the opposite of what occurs in the factors. X equals negative 2. X equals 6. So, great. Quadratics. There's definitely you will definitely need to use quadratics to solve. So don't forget these methods. You've got factoring. You've got square roots. And of course, everyone's favorite, the quadratic formula. But try not to rely on this too much. Next. So this is just another step up. Solve for x using any method. Check for extraneous solutions. So when they say any method, they mean any method. You could calculator it to find all the intersections. I'm going to use the calculator to just verify my answers are correct. So to solve for this, I got to solve for the x. Got to square both sides to get rid of that square root. X minus 1 equals 2 squared. 2 times 2 is 4. I need to get rid of the 1. Add 1 to both sides. X equals 5. And to make sure it works, there's two methods. You can either graph it to see if it does intersect at 5, or you can plug it in. I just want to plug it in. I don't feel like opening a calculator. So just plug it in there. If I do plug it in, what am I going to get? 5 minus 1, and that's 4. The square root of 4 is equal to 2. So since this answer works when I plug it in, this is a good solution. It's not extraneous. All right, 7 here. Well, same thing. Square both sides. And make sure you put parentheses square. These cancel out. Then I get x minus 1. Oops. X minus 1. And another x minus 1. Like so. I've got to multiply all this, meaning I've got to use the distributive property, x times x. So if you do all of this, you are going to get, and I'm just writing the answer quickly, that's x squared. That's a negative x and another negative x, making negative 2x. Negative 1 is positive 1. All right, this is definitely a quadratic because you have a square there. Let's move everything to the same side. Move everything to where the x squared is. So I'm going to subtract 5x. I'll do this all in one step. Let's subtract 5x and add 9 to both sides. So if I do this all in one step, the x squared comes down. Negative 2x and negative 5x is negative 7x. 1 and 9 is 10, just at the answer. These cancel, 0. Is this factorable, or do I have to use the quadratic formula? So what multiplies to 10? But adds to 7. That in that case would be 2 and 5. So 2 times 5 equals 10, and 2 plus 5 equals 7. However, I do want negative 7, meaning then 2 and 5 must both be negative. So let's factor this to x minus 2 and x minus 5 equals 0. The solutions are always the opposite, so x equals 2, x equals 5. At this point, there's a lot to plug in. So I may end up being lazy here and just say, I want to put this in the calculator. So let's graph both of these functions and see where they intersect. So my first function was x minus 1. So let's put x minus 1. Second function was square root of 5x minus 9. Second, square root 5x minus 9. Okay, just make sure the functions look good. We're going to graph it, see where they intersect. So you got a line here and a little curve there. Does it cross in two places? Does it cross at 2 and 5? So here's 1. So it does cross at 2, 3, 4, 5, and it looks like it also crosses at 5 as well. So maybe we'll zoom in a little bit. It certainly crosses at 2. Does it cross at 5? I'll change my x maximum. Let's just make it 7. It needs to go higher. Maybe make them y max 7. So yes, it crosses at 2, 3, 4, and it also does cross at 5. So you can use the calculator to verify whether they intersect. You could also use second in table and see if they reach the same values. So if you look at 2, which is one of the answers, they both are at 1. If you go to 5, they are both at 4. So that's just another way to check. There's a lot of different ways to get your answers to work. So they are both real solutions. Sorry, I can't use the word real. They're both actual solutions, not extraneous. All right, moving to 8. 8, do the same thing again. Square both sides. These cancel. I got 30 minus 2x equals x minus 3 times x minus 3. All right, so that becomes 30 minus 2x. I'm going to do the same thing I did to the other side. Sorry, I mean the one above. This would become, if I do all the work, x squared minus 6x plus 9. Negative 3 times negative 3 is positive 9. Move everything to one side. Move everything to the side with the x squared, meaning cancel everything from this side. So, subtract 30 from the numbers and add 2x here. 30 minus 30, cancel, cancel. I got 0 equals x squared. That's minus 4x. That is negative 21. Is this factorable? Anything that multiplies to 21 and adds to 4. You got 3 times 7. Yeah, 3 times 7 works. In this case, I need a negative 4, so I need to make this 0 equals x plus 3, x minus 7, leading me to two answers. X equals negative 3, and x equals 7. So we're going to check which ones are extraneous. So with the first one, square root of 30 minus 2x. And the next one is just, let's clear this, x minus 3. Graph and see where they cross. Do they cross at negative 3 and 7? 1, 2, 3, 4, 5, 6. They cross at 7. They don't cross at negative 3, meaning negative 3 must be extraneous, and 7 is the actual solution. 7 is the actual solution. This one is extraneous. Simply because it doesn't work when you use it in the problem again. All right, this last one here is tricky. I can't just square both sides because this minus x is in the way. So let's add this out. That would become square root of 4x plus 1 equals negative 1. I'd rather do x minus 1. You could do negative 1 plus x, but x minus 1 seems easier to me. And do the same thing we did in the other problems. Square both sides. These cancel. 4x plus 1 comes down. X minus 1. X minus 1. Make sure you distribute. So that becomes 4x plus 1 equals, that's x squared. And if I do all of it, it's minus 2x plus 1. Move everything to one side. So let's get rid of the 4x here. Let's get rid of the 1 here. Cancel, cancel. 0 equals x squared minus 6x. These are gone. Oh, great. I only have 2 terms now. Well, I can't use square roots because I don't have x squared in a number.
Good afternoon.
Gotta pause. All right, I had to pause for the high school plus announcement. So this would be, oof, lost train of thought. It's x squared and not a number because this is 6x. So here I need to factor using a greatest common factor. Meaning, what do these two have in common that I can take away? I can take away an x from both. So I'll do that. Take away an x. If I take away an x, this is left with just 1x. This x is gone, leaving a minus 6. In this case, I have 2 answers. Remember, you're asking for the answers are also asking for the zeros. So this is x equals 0 is one of them because there's just an x here. X equals opposite of negative 6, positive 6. So we got to check if they're extraneous or if they're actual solutions. So go to the calculator, y equals, let's erase this, that's square root of 4x plus 1. I put a times, not an x. And Oh, actually, I forgot this part. There's a minus x. That minus x is outside. So you notice that I pressed outside of the square root. Minus x. So it's outside. If it's inside, it's wrong. And this should just be -1. Let's see if they cross at those two values. Oh, there's a syntax error. What's going on? Oh, I see. Instead of I should have put negative this spot. So I'm sure you've all made this mistake a few times. They only cross once. They cross here. They don't cross at 0. Therefore, 6 is the actual solution. X equals 0 is extraneous. Right, so these are solving a radical. It looks like for all of these, you will need to use some kind of factoring at some point. All right, next here, this is more on polynomials. So we're looking at the polynomial function and answering all of these questions. What is the degree? The degree is 1, 2, 3, 3. And behavior, if I'm going to the right, what happens? The right side goes down, negative infinity. The left side goes up, positive infinity. X-intercepts, they cross the x-axis here and here. -3 and 0. Y-intercepts, it crosses the y-axis at 0. Is this an odd or an even function? In this case, well, technically, it's neither odd nor even. This is considered a neither. For odd or even functions, they need to be exactly symmetrical. So with an even function, the left and right sides need to be exactly the same. With odd functions, the shape needs to be the same if I rotate it. So if I take this and I flip it upside down, so let me do this. So if I take this and I flip it upside down, is it going to be exactly the same here? Let me do this one again. So in order to be an odd function, it needs to look like I rotated the whole image upside down. If I flipped the whole image upside down, it would also appear here. So this is not symmetric about like the origin. So it's just neither odd nor even. Relative maximums. The maximum is right there. This is at -1, 4. Remember, a relative maximum is like the top of a hill. -1, 4. There's no other little hills. And relative minimum is like a bottom of a pit. So here's the bottom. -3, 0. Right? Last thing is increasing intervals and decreasing intervals. So it is increasing once here, and it is decreasing here and here. Decreasing here, and decreasing this way. So let's do the increasing intervals first. It's increasing from the -3 all the way to the -1. So it's increasing from -3 to -1. Don't use the y values, only the x values. For decreasing intervals, it starts decreasing. So if it starts decreasing off the graph, that means it starts from -infinity. It continues to decrease until it gets to -3. It decreases a second time, so we could put and. I usually put u. U is just union. It just means it's a math and. It continues to decrease from -1 off the graph, which means it goes from -1 to infinity. All right, moving it down. So same things here, more graphing. What is the degree? The degree is 1, 2, 3, 4. Looking at the end behavior, the right side's going up and the left side is going up. They are both infinity. X-intercepts, it crosses the x-axis at -1 and 3. Crosses the y-axis at, what would you say, that's 8 or 9? I think that's a 9. Yeah, that's a 9. I'm going to ask that we actually skip this odd or even function. For this assessment, this concept won't actually really matter. Relative maximums, they occur here. That's at, what is this? 1, 16. Relative minimums, well, they're both down here. They're actually also the x-intercepts. So they're -1, 0, and 3, 0. Increasing intervals, it's increasing twice and decreasing twice. It's increasing up here, increasing here. It is decreasing there and decreasing there. So for the increasing intervals, increases from -1 all the way to not 16, 1. Always use the x values. Never use the y values for intervals. The second one is from 3 all the way off the graph. If it's off the graph, depending on which side you're on, in the case it's the right side, so that's going to infinity. Decreasing intervals, it's coming from off the graph, -infinity all the way to -1. And then from here, 1 to 3. And if you want to just check if your intervals are right, they should all match up. So -infinity to -1, -1 to -1, and then a 1 to 1, 3 to 3. So they should all kind of have a nice flow. All right, next one here. So this is just more practice. There is a question where you'll need to be graphing for sure. Let's remove this odd or even part. That's actually not necessary here. So looking at the degree, what's the degree? 1, 2, 3, 4, 5. Well, the degree is odd, so it doesn't mean odd or even function. The degree is odd, meaning it's supposed to go, it's going to look something like this. Means the left side's going to be going down, the right side's going to be going up, but the inside will not necessarily look like this. So the right side is going up, the left side is going down. X-intercepts and y-intercepts. Well, for x-intercepts, when does it cross the x-axis? I know it crosses, and they're the opposites of the zeros, at opposites of the factors. -2, at +2, and -1. These are my 3 x-intercepts. Y-intercepts, I'm just going to calculate it for the rest of this. So let's actually graph this monster. So just putting in the function. Oops, not plus. -2, there's a square button there. And x plus 1 squared. It should be good. Graph it. That's pretty big. And if you take a look at this graph, you see it goes all the way up to 15. So to make it easy for us, let's go to our window and change your y maximum value to 15. That might make it easier for us to see this. There you go. So it goes up, up, and even higher. So it looks like it. In this case, let's table this. Let's go in the table to find a lot of the values. Right? -100, that's huge. So -2, 0, -1, 0, -2, 0, -1, 0 is 1. What else have I got? 0, 8, 0, 5, 6, 7, 8. 1, 12, and 2, 0. 112, and 2, 0. Now I can't just start connecting it like this. That is not acceptable. It needs to match the existing shape of the graph. So it's coming from off. It passes through the first 0, hits the other 0, makes kind of a maximum at some point, hits the third 0, and goes off to infinity land. So let's actually draw this then. So it's going up. It passes through the 0, hits 1, goes through the intercept, hits the other one, and then goes up like this. So for these questions, you don't need to be that specific with your graph, because I know this part's a little weird. How would you have been able to get this part correctly? Most people would have just connected it like that. That really doesn't matter here. We just want a good sketch. Not a perfect one, just one that has the proper end behaviors and making sure you hit the x and y intercepts. All right, are we done with graphing yet? All right, we're pretty good with graphing. We're done with that. I put a star on this one because this one is, there's definitely a question like, it's very similar to this on the actual test. So, experiments with a covered cup of coffee show that the temperature in degrees Fahrenheit of the coffee can be modeled by the following equation. So looking at this equation, note, that's 68. That is the temperature of the room. Let's just call that the room temperature. Of this function, where time is measured in minutes after the coffee was poured into the cup. So first thing it asks is, what is the temperature of the coffee the moment it is brewed? The moment it is brewed means T equals 0. What happens at 0? So plug it in. F of 0. If I plug in 0, I get 68 plus 112 e to the negative 0.08 times T, which is 0. Well, if I'm multiplying 0, this whole thing is 0. This becomes 68 plus 112 e to the 0. Well, e to the 0 is just 1, right? And if you multiply by 1, nothing happens. So this e to the 0 actually just completely goes away. I'm left with 68 plus 112. 68 plus 112 meaning 180 degrees Fahrenheit. So the initial temperature, meaning you just plug in 0. Next one is, how long does it take for the coffee to cool to 98.6 degrees? So it wants to know, when is the temperature equal to 98.6? So you'd set the equation equal to 98.6 and solve for the time. All right, give yourself some space. This is a long solving question. All right. Well, I'm solving for t, which means I need to get rid of this, get rid of the e, get rid of the 112, and get rid of the 68. First thing I will do is subtract the 68 from both sides. 98.6 minus 68 is 30.6. These cancel. 112 e to the negative 0.08 t. Next, I want to divide out that 100. Sorry, the 112. Now, I could put this in the calculator. However, it's going to be a pretty long decimal. I don't really want to mess with it, so I'm going to leave this as a fraction right now. So leave it as a fraction. 30.6 over 112 equals e to the negative 0.08 t. Now, I'm solving for t. I need this 0.08 to go away. I need this e to go away. So we learned a long time ago how to get rid of e. To cancel an e, you need to put an ln on both sides. So to remove an e, you use ln. To remove a 10, use log. To remove a 2, you would use log base 2, but don't expect to see this. This doesn't actually occur on the test. I shouldn't cross it out. So let's take ln of both sides here. So it's going to be ln of 30.6 over 112 equals ln of e to the negative 0.08 t. The ln and the e cancel out, leaving just this. ln 30.6 over 112 equals negative 0.08 t. Finally, I can just remember that thing right here. So divide, not add, negative 0.08. Divide, negative 0.08. These cross out, leaving t equals ln 30.6 divided by 112 divided by negative 0.08. So fun fact, the test actually says that you can leave it in an exact answer, so you may not have to deal with this. But let's find the answer anyway. So let's put this in the calculator. I don't need this graph anymore. So what am I putting in? ln, which is right here, of 30.6 divided by 112, close parentheses, and divide again by negative 0.08. 16.218. Let's round that to 16.219. And this one's minutes. So M-I-N-S, minutes. Oof, that was long. For C, what is the lowest temperature the coffee can cool to? You could plug in really, really, really big numbers and just see if I don't know, let's make this coffee cool for 3 years and figure out how long it will be. You don't need to worry about that. We determined that 68 is the room temperature. If 68 is the room temperature, then you can't get any lower than the room temperature. So the lowest temperature that the coffee can cool to is 68 degrees. And this is because since you can't get colder than the temperature of the room. Then the room's temperature. Right, so with the word problem, these two are just general solving practices. So I'm solving for the t, which means I need to remove the 3, get rid of the 10, and get rid of that 5. First thing to do is divide the 5. Cancel. 10 to the 3t, if you divide these two, you get, what do you get? 85. How do you get rid of a 10? What did I say up there? You need to use log, log. So I got to take the log of both sides. So I'm going to do log 10 to the 3t equals log 85. Log 10, they all cancel out. I'm left with 3t equals log 85. Now I need to divide the 3. That cancels, so I got t equals log 85 over 3. If I put this into the calculator, I will end up rounding it to 0.64 because it asks for 2 places after the decimal point. So just 2 is fine. For B, this one I have to use E, so I'm going to first divide the 3 on both sides, cancel, e to the 5t equals this divided by this. That is 400. To remove an e, I need to use ln. So I'm going to put ln of both sides. This is gone. 5t equals ln of 400. And just like the one up here, let's get rid of that 5. T equals ln 400 over 5. If you put this in a calculator, you will get about 1.20. So solving with log and ln. If you see something with a 10, you use regular log. You see something with an e, that means you should be using ln, the natural logarithm. Right, still got quite a ways to go. Right, forming this operation here, we're subtracting. So this is going to be 1 plus 4i minus 2. Remember, if you do a minus and minus, you distribute the negative. That becomes plus 5i. 1 minus 2 is negative 1. 4 plus 5 is 9i. That's done. Next, I'm adding it. Since I'm adding it, I don't need to worry. I just mush everything together. 1 plus 2 is 3. 4i minus 5i is negative I. 3 minus I. This one's another subtraction. Distribute the negative sign. 4 minus 9i minus 6 plus I. Combine like terms. 4 minus 6 is negative 2. Negative 9 plus I is negative 8i. We go here. So this one's adding and subtracting. Do you need our multiplication? So I do need to multiply this. So 2 times 1, 2 times 5i, negative 3i times 1, negative 3i times 5i. So 2 times 1 is 2. 2 times 5i is 10i. Negative 3 times negative 3i, that is negative 15i squared. Combine the i's together. That's, what is that? Plus 7i minus 15i squared. Remember, with imaginary numbers, I squared is negative 1, meaning this little I squared, it's got to change to a negative 1. Negative 15 times negative 1 is positive 15. So you got 2 plus 7i plus 15. Don't leave this. It's not done. What's 2 plus 15? That's 17. So my final answer is 17 plus 7i. So fun fact with this, you are allowed to just put this in the calculator. If it says use any method. I know in one test it did say use any method. So you can just put parentheses, 2 minus 3. There's the I button right there. I. 1 plus 5i. If I did it correctly, it should give me, yep, 17 plus 7i. So you have a calculator that can do it for you. So just be aware that this is a lovely, lovely tool for you to use. And then what about this last one? I'll just do it by hand just because it helps us practice distributing. 1, 2, 3, 4. 1 times 3 is 3. 1 times negative 6i is negative 6i. That is positive 6i. And these two multiply to get negative 12i squared. Well, the 6i and the minus 6i will cancel out, leaving 3 minus 12i squared. Remember, I squared is negative 1. So that should be 3 minus 12 times negative 1. So these multiply to become positive 12. Oops. 3 plus 12 is 15. Oh, fun. So all of these, your answers ended up being complex, 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 complex. However, this one, that's a real number. Real because there's no I involved. Okay. Oh my goodness. Why did I make this so long? For very large positive values of x, if you plug in the numbers, you're going to list the expressions from least to greatest. So this is not what looks the smallest or what looks the biggest. It's what is if I plug in a number that's basically infinity. So for this, the rule is always, the higher the exponent, highest exponent is always greatest. So if you want to go from least to the greatest, what's the lowest exponent? The lowest exponent is actually this one. Because the exponent, there's nothing here. The exponent's actually 0. It's x to the 0. So this is actually my smallest expression. So this is the smallest one. What comes next? Well, what's the next lowest exponent after 0? Is there anything with a 1? Yes, this has a 1 there. 99x plus 200. Afterward is a 2. Yep, here you go. Oh, nicely in order. X squared minus 14x plus 9. After 2, is there a 3? Yes, there is. What is that? That's a 10 million. Well, the 10 million doesn't mean anything. X cubed. What comes after 3? 4. So there's no 5, no 4, 5, 6. There's certainly 7. X to the 7 comes after that. All right, and I'm running out of room here. Well, great. 7, I got these weird things with x's. So these two are exponentials. Exponentials are always like the largest exponents, because you can put any number you want, right? You could put infinity as an exponent. In this case, this one will go faster because it's got a higher number. So it'll go greater. 3 to the x. And the last one is 10 to the x. So highest exponent is always the greatest. But exponentials, here, maybe you having x as an exponent, is always, like always, way greater. And then you just look at whichever has the higher number. All right, this is very familiar. We definitely had this on a pretty recent test. Subtract f minus g of x. So you're not multiplying x. This means you're subtracting the two functions. This is the same as saying what's f of x minus g of x. They just didn't feel like writing x twice. So, well, what's f of x? That's 2x squared plus x minus 6 minus g of x, which is 3x minus 4. Make sure you put those parentheses there. This becomes 2x squared plus x minus 6 minus 3x plus 4. Combine like terms. 2x squared is 2x squared. X and minus 3x is minus 2x. Minus 6 and 4 are minus 2. Coincidental. 2x squared minus 2x minus 2. For B, they're asking us to add them. It's easier than what we did on the above. Plus 3x minus 4. So I got 2x squared. X and x is 4x. Minus 6 and minus 4 is minus 10. And then you can leave it like that. Last one is asking us to multiply them. Multiplication. I'm multiplying 3 terms by 2 terms. That's pretty complicated. So here we can use that box method. So I'll create kind of a 3 by 3 box. Sorry, a 2 by 3 or 3 by 2. I don't remember. Essentially, I want 3 spaces by 2 spaces. So this is the 2x squared. This is the plus x. This is the minus 6. And the 3x minus 4 goes on this side. So this is a nice way to multiply it that's not too overwhelming. 2x squared times 3x is 6x cubed. X times 3x is 3x squared. These two become minus 18x. 2x times minus 4, that's negative 8x squared. X times minus 4 is minus 4x, and that is positive 24. And now I just combine like terms from the inside. No multiplying the inside. You're just making it easier. So what does this come out to be? That comes out, just the 6x cubed comes out. These two come out together, making minus 5x squared. These two add 18 and 4. That's negative 22x. And finally, 24. Oof, that was pretty long. All right. Ooh, long division. All right, this is one of the last things we gotta do. Just one more page though. So I'm dividing f of x, which is this thing, by x plus 6. So x plus 6 is being divided, well no, this big thing is being divided by x plus 6. When you're doing long division, make sure you focus on the first terms. The first terms, the x and the x cubed. So what happens? X times what is x cubed? That's x squared. X times, and then you need to distribute. X squared times x is x cubed. X squared times 6 is 6x squared. Remember, you are subtracting them. X squared minus x cubed, x cubed and x cubed, they cancel. 5x squared minus 6x squared is just negative x squared. Got to bring down that minus 12x. What are we multiplying x to make it a negative x squared? That's a negative x, because I need the x to be squared, but I also need it to be negative, so multiply by negative x. X times negative x is negative x squared. Negative x times 6 is negative 6x. Subtract. These cancel. Negative 12 minus and minus is plus. Negative 12 plus 6 is negative 6x. Minus 36 comes down. What do I multiply to x to create a negative 6x? Simply a minus 6. Negative 6 times x is negative 6x. Negative 6 times 6 is negative 36. If I subtract these, that's gone. So what does that tell me? This question leads directly into problem B. I divided and I ended up with a 0 at the end. This means that I've got my remainder is 0. So is this a factor? So yes. X plus 6 is a factor of f of x, because the remainder f of negative 6 equals 0. So you could just say the remainder is 0. However, I want to bring attention to this notation. X plus 6 is a factor. That means if I plug in a negative 6 into the equation, I'm going to get 0. So this was called the remainder theorem. This was in the front. There is a question that asks something using the remainder theorem. So make sure you understand what this notation means. That means this is the remainder, because I divided it by x plus 6. If I divide by x plus 6, and I get no remainder, that means if I plug in negative 6, I should also get no remainder. And in general, if you get a remainder of 0, it means the divisor is a factor. It means the divisor is a factor. C asks to write a factorization, meaning I want this to be written as a bunch of x little pieces there. Well, I divided by x plus 6, and I got this as my answer. Meaning I can multiply these two to get that. So I already have a factorization. So let's write the two parts from A. So this whole thing is actually turning into this. So yeah, this times this does give you this. I can actually continue further here And I can factor this even further, x plus 6. Can I factor this? Anything that multiplies to 6 and adds to 1. That would be 3 times 2. So I could keep going. X minus 3, x plus 2. Because negative 3 times 2 is negative 6. Negative 3 plus 2 is negative, and then there's a 1 there. So this is officially my smallest factorization I could make. And with the factorization, if I wanted, I could get the zeros. I could get the solutions. The solutions would be x equals negative 6, x equals 3, x equals negative 2. Right? So these would be the solutions. This is not a factorization. I'm just adding extra stuff. So how about I just write extra here? So this is because on the test, there is a question asking what are the solutions. So after dividing it, you do need to go a step further. You may need to factor it, or possibly use quadratic formula, hopefully just factoring. All right, and finally the last page. Oh my goodness, I'm getting very tired. So you want to divide ax by bx. Ax is this, bx is that. All right, let us divide. I'm going to stop color coding. This is too much work. Let's just divide it. Okay. All right, so if I'm dividing this, what do I do first? Focus on the first terms. X and x cubed. What do I multiply to make x into x cubed? That is an x squared. X squared distributes. X squared times x is x cubed. X squared times negative 5 is negative 5 x squared. You are subtracting. These cancel. 5 minus minus is a plus, so 10 x squared. Bring down the minus 12x. So great. What do I multiply the x to make a 10x? That's a 10 plus 10. 10 times x is 10, sorry, 10x. So I need an x squared, right? So 10x squared. 10x times negative 5 is negative 50x. Subtracting. These are gone. Negative 12 minus and minus is a plus. So negative 12 plus 50 is 38. Bring this down. What do you multiply to x to make 38x? A 38. 38 times x is 38x. 38 times negative 5, I already did this. Negative 190. I need to subtract now. Cancel. Negative 36, that's a minus and a minus. Minus minus is plus. So I add it to get 154. I got a remainder. Huh. If you get a remainder, that means what you divided by is not a factor of a of x. So no, it is not a factor. Nope. X minus 5 is not a factor of a of x. Because the remainder and the remainder is a of 5, right? If I have this as something I divided by, the opposite is what I plug in to get the remainder. That means a of 5 is 154, which is not 0. And if you have a remainder that's not 0, then it's not a factor. It means you have an extra. The last question here. So this isn't something we talked about in class, but this is one way to write the actual division out as another expression. So rewrite the division, ax divided by bx, in the form qx plus rx over bx, where qx is the quotient. Quotient means it's the answer I got. Rx is the remainder. So ax over bx. Ax is the big polynomial, divided by bx, which is the thing I divided by, the divisor, equals qx. Qx is what I got as an answer. It's this up here. So that is q of x equals x squared plus 10x plus 38. I got to add rx. Rx is the remainder, which is 154, divided by b. B is just what I divided by, x minus 5. So this is officially that form. All right, so I've gone through everything. Time to record another video.